Assalamualaikum and hi to everyone that watch my video. My name is NOR ASMALYANA binti KAMARUDIN, and in this video I'm going to present my final year project 1 entitled to study the influence of empathy fruit bunch EFB fiber on the mechanical properties of seaming board used in paneling. My supervisor is TS Azman bin Jaafar. Okay, for the abstract, the use of oil palm empathy fruit bunch, or known as OPEFB fiber in organic composite, has been developed in order to displace the present material predominantly wood fiber. OPEFB fiber is readily accessible as a palm oil is one of Malaysia's largest agricultural crops. The empathy fruit bunch EFB was collected for oil palm mill that located around Air Hitam. Material used in the making of seaming board are seaming, fiber, water and sand. The ratio used is 20%, 25% and 30% to determine the optimal ratio that's suitable for EFB fiber seaming board. This research focuses on the effect of using different ratio on mechanical strength properties of EFB fiber seaming board. A test sample was performed for thickness swelling TS and water absorption WA, modulus of rupture MOR, modulus of elasticity MOE, and compression strength. The expected result for this study is that the higher fiber content which it will increase MOR and MOE. But for compression strength, it will reduce due to the increase of fiber content in seaming board. Then, for thickness swelling, the presence of higher fiber content will increase the presence of void space and enhance the water absorption. For background of the study, Malaysia is one of the main producer of oil palm. Besides, it is most profitable crop, so more long-term strategy for its capacity because resources in structural and non-structural implementation are needed. The use of waste material for construction material has become increasingly prevalent in building industry. Natural fiber composites are very cost-effective, low energy consumption material. They are both environment conscious and long-lasting. Biocomposite material are often used to reduce toxicity and environmental impact. The use of abundant natural resources would help to minimize toxic pollution. According to the finding, the combination between EFB fiber and seaming will increase the efficiency of biocomposite material. Natural fiber can be used as a binder for EFB products since it contains no residual oil. In this study, I have 3 problem statements. First, compatibility issues involving seaming and fiber caused by the presence of glucose and oil tends to hinder seaming hydration considerable. From the previous research has proposed that the most successful approach for resolving this problem is to pre-treat natural fiber along with sodium hydroxide and to speed up the seaming current period that may increase natural fiber compatibility with seaming. The second one is the growth in a plantation palm oil in Malaysia causes the environmental issues and created solid waste in terms of abundant quantity of EFB. According to MPOB 2013, Malaysia fresh fruit bunch FFB production increased to 99.85 million tons in 2011 from 97.38 million tons the year before. And the last one is researchers are looking at new natural form lignocellulose fabric to start replacing the commonly existing fiber in the building industry. I have 2 objectives of research. Number 1, to identify the effect of using different ratio on mechanical strength properties of EFB fiber seaming board. Number 2, to determine the optimal ratio of EFB fiber that is suitable for EFB fiber seaming board. Scope of my study is I use empathy fruit bunch EFB as the reinforcement of seaming board. The ratio that I use 20%, 25% and 30%. The test that we conducted is modulus of elasticity MOE, modulus of rupture MOR, thickness swelling and water absorption, and the last one is compression strength. The study is focused on the mechanical properties of EFB seaming board. EFB fiber will be collected from oil palm mill that located around Air Hitam. Size of seaming board for MOR, MOE and thickness swelling and water absorption is 210 mm times 210 mm with the thickness 12 mm. Then for the compression strength, the size used is 1 150 mm times 150 mm times 150 mm. The material that used in this cement board is cement, water, fiber, and sand. I have 4 significance of my study. First, to enhance fiber in the production of cement board, reducing waste and environmental problem. Number 2, the researchers are able to learn more about the impact of the cement board ratio. Then, through this study, we can know the ratio, pre-treatment, and material that's suitable for EFB cement board. And the last one is manage to ensure that fiber is durable and can act as a reinforcement in the cement board. I'm going to share what is cement board. Cement board is a mixture of cement and reinforcing fiber that is commonly utilized as a tile backing board. It also known as a building material, which also can use as an interior surface and also roofing material. Then, cement board has a higher long-term stability. According to the previous study, cement board is a construction substance made up mostly of timber, cement, and chemical that are usually used in prefabricated building. During the lifespan of cement board, the fiber cement board can sustain in variety of environmental conditions, humidity, and temperature, including a temperature of 0 Celsius in 24 hours period. Empathy fruit bunch, or also known as EFB. EFB is a lignocellulosic material, mostly including cellulose, lignin, and hemicellulose. EFB fiber is a biodegradable and non-hazardous product. Natural product has a high potential for use as a composite material because it is inexpensive, sustainable, biodegradable, and has the capacity to minimize CO2 emission. The EFB fiber are free of toxin, non-carcinogenic, and contain soft parenchyma cell. So I'm gonna present my methodology. As you can see, this is my flowchart. I start my project with preparing the material needed, which is empathy fruit bunch, cement, sand, and water. After prepare all the material, I'm gonna start with cement board fabrication process. In this process, there are a few steps, which is first we need to weight the material, then mixing all the material using mixer machine, forming, pressing to get the desired thickness, curing and cutting according to the size needed. After settle with all the process, we're gonna proceed with laboratory test, which is thickness swelling and water absorption, MOR, MOE, and compression strength. After settle with test, we need to do result and analysis. This is my material preparation. The main material for cement board are cement, sand, fiber, and water. The ratio I choose is 20%, 25%, and 30%. The control sample that selected are 1:3:0 proportion, which is cement, sand, and fiber. The initial water content is 50%. For water cement ratio 0.85%. The fine aggregate is clean river sand, which a fine modulus from 2.0 to 3.5, which a particle maximum size of 4.25 mm. The size of fiber is around 0.5 cm to 1.0 cm. The table is about the ratio to be tested. I will refer all the ratio in the table to do my laboratory test. This is the size of cement board. The picture number 1, the size of sample for compression strength, and picture number 2 is the size of sample for thickness swelling and water absorption, MOR and MOE. So for fabrication process, as I mentioned just now at the flow chart, it has a few steps. Number 1, weight. We need to weight all the material, then mixing all the material using a mixer machine. Number 3, forming. All the mixed substance is pouring into a wooden mold, which of the measure 210 mm times 210 mm and 150 mm times 150 mm. Number 4, pressing. It will be stretched and flattened by hand to achieve the desired thickness. Number 5 is curing. The cement board specimen are curing at ambient temperature needed 48 hours before the mold containing the cement board sample are unclaimed 26 days. And the last one is cutting. I will cut the cement board according to the size needed for do a test, such as for a MOR and MOE. The size that I will cut is 210 mm. times 50, and for the thickness swelling and water absorption is 50 mm times 50 mm. This is the test that I need to conduct during my study, which is thickness swelling TS and water absorption, modulus of rupture, modulus of elasticity, and compression strength. In the table is the minimum required for specific OPC bonded particle bulk. So I need to refer this table to know that my test is achieve the requirement or not. For example, I need to achieve 1.5% for the thickness swelling. Okay, for expected result, I expect that MOE will achieve the optimum with the ratio 30%. It is because the fiber can act as a reinforcement in a seaming board to enhance the strength. Then for MOR testing, for sample with ratio 25% and 30%, will display MOR values significantly higher than others due to the increase of fiber quantities in seaming board. Then, for compression strength, I think it will be decreased with the increase of fiber content. It is because due to the less efficient packing of the fiber and matrix that may causes the work volume to increase. From the previous study, many of them said that when increase of fiber content, the compression strength will decrease. Then the last one, for the thickness swelling, the presence of higher fiber content will increase the presence of void space and enhance the water absorption. So this is all my references that I used during my study. Page 1, page 2, page 3, and the last one is page 4. So this is my Gantt chart for final year project 1. So that's all from me. Thank you so much for your time, especially to my panels.